Hey guys, let's take some notes about right triangles and Pythagorean theorem. Okay, so these come up every once in a while. You will never have to write a proof from scratch. We kind of do this together in class, or I guess you're kind of taking guided notes at home. But you maybe would have to put these in order. So that's why these are important to go through. So given that the triangle is a right triangle, so we can also tell that from the picture, prove the Pythagorean theorem using similar triangles. So you're like, wow, okay, can I prove, not that this is given, imagine it wasn't given or you were born before that formula came up. Okay, so the first step in this proof is I have to draw an altitude xw. Okay, so here's x, but I got to draw an altitude. So I need to flip this thing on its base, right? And drop an egg, ooh, from x. So I'm just gonna line this up, ooh, splat. I get an x. So that's an altitude, and I'm gonna call that w. So now when I flip it upside down, it looks like an m. So w, okay. Right, so draw an altitude xw, step one. Step two, we need to prove that these triangles are similar, and that's what we've been working on previously. So we have three similarity theorems. Similarity, it's angle-angle similarity, side similarity, and side angle side similarity. And just this is a shortcut instead of writing out the word similarity. That's what this symbol means, similarity, okay? So I call this mommy, teenager, baby, because there's this little one, and see how that would be a right angle? So there's a little triangle made here, a medium triangle made here, and a big triangle. So instead of comparing the mommy and the baby, there's actually a teen right here. And we're gonna prove all three triangles are similar. Let's do it. So how would we do that? Well, first I want to prove that the mom, this one, is similar to the baby. So I probably should draw it off to the side. We always say strategy one. So drawing this off to the side, this is A, and I need to come up with more lengths. So AB, I could call this length D, the altitude. Let's call this length E, this little side of the baby. And W is this point here, so that doesn't really help me. I need to name this length right here, E, I'll call that length F. Okay, and then again, don't forget that the whole length, the whole hypotenuse of the mom, we already named C. So there we go. So we got lots of lengths here, lots of sides of the little one, the medium one, and the big one. So let's compare the littlest one, A, E, D, with the mom, A, B, C. So if we compare the two, how would we know they are similar? Well, notice that the mom has this angle Y here. The mom has the angle Y. And notice the baby also has this angle Y. So what is the name of the baby? It is triangle YWX. And the mom is YXZ. YXZ. So we know they at least have one angle. The other thing is they both have a right angle, right? So the baby has a right angle here and mom has a right angle there. So that's angle-angle similarity. So let's write out our evidence. We know that angle W in the baby is congruent to angle X in the mom, because all right triangles are congruent, or all right angles, excuse me, are equal to each other. All right angles are equal to each other, and they're both right angles. We also know that they both have angle Y in them. So angle Y is congruent to angle Y. We call that reflexive property. Okay, well, we have two angles that match, so we know that this one and this one are similar. So we know triangle, the mom, XYZ, is similar to the baby. We got to just make sure we go in the right order. So I went from the right angle to the angle we match and the other. So right angle, angle that's a match, and the other. So the baby would be WYX. Okay. So step one, prove the three are similar. I proved the first two. Now let's compare the teenager to the mom. So we still have our mom here. What about this teenager? Well, notice the teen has a right angle, and the teen has this other angle Z off to the side. So if I compare it with the mom has a right angle, and the teen has a right angle, and mom has angle Z, and so does the teen. The teen has this angle Z. So it looks like for pretty much the same reason, so let's write that out. Both the teen and the mom have a right angle. The teen's right angle is W. The mom's right angle is X. Both of those are right angles, and we know right angles are congruent. So what else? There's a second angle, angle Z in the teen. See it there? And both of them are called angle Z. And so that's just our reflexive property again. But it says in our steps, we need to prove all three. So we've proven the mom and the teen. So the mom, XYZ, is similar to the teen. Let's go in the same order. So when I name the mom, I go the right angle, this other angle, and the two necklace. So I need to go right angle, the other angle, and the two necklace. So that'd be WXZ. Okay, so I've proven the big one is similar to the littlest, and the big triangle is similar to the medium triangle. And so it should logically be able to pull all this together. That's called transitive property. So we can say logically that the mom, XYZ, is similar to the baby, which is also similar to the teen, because transitive property. If one thing goes with another and the other one goes with a third one, then the first and the third one have to go together. That's a logical step. Transitive property. Okay, so step 3, what do we have to do next? We need to write proportions using the legs of these triangles, using the sides. Okay, so let's do it. Now we actually name these sides so it goes a little A, B, C, and D, A, E, D. Let's do this teenager one. I guess this side is F, this is D, and that is B. Okay, so now let's set up some ratios. And we did this before. So order the sides least to greatest on the baby, and see how they have A and E, and I have a short side here, a short side and the longest side. So ordering them least to greatest, E is the shortest side of the baby, and A is the hypotenuse. Now going in order least to greatest on the mom, A is the shortest side, and C is the hypotenuse. Now notice, if we cross multiply, we actually get an equation that forms. We have A times A would be A squared, and E times C would just be E times C. Okay. Now, can I do that with the mom and the teen? I think so, yeah. So see how the mom and the teen have a B? So let's use this medium side of the mom and the longest side of the mom. So, and let's compare that with the teen. So the teen has this medium side F, and its longest side is B. So if we order least to greatest, medium and then long, we get FB. And let's do the same pattern here on the mom. The medium side here is B, and the longest side is C. Now, notice if we do the same technique here, if we cross multiply, then we get B times B, so we get B squared. Do you see how we're getting closer to the ingredients we need for this? This is what we're trying to prove here. So B times B, B squared, F times C is just F times C. Okay, so we're basically ready to go to the last step. We just need to write an equation and walk through our steps. So let's write an equation. And to do that, we should be able to say this equation right here. So let's start right there. A squared is equal to E times C. Well, what else do we know now? We also know we could add these two equations, right? So if we added these two equations, A squared plus B squared, it would equal to A squared we know is EC, and B squared we know is FC. So we're really just using the addition property to combine these two together. Okay, we're getting close, right? What are we trying to do? We're trying to get our equation to look like that without just assuming, and we're really close. We're almost there. So what could we do to make this a little different? Notice both equations have a C. So if we rewrote our problem, but we factored out the C, we would have E and F left over. So see how it's kind of like the opposite of distributing or factoring out. We factored out. E and F. Last step. E and F. We know from our picture, E and F, we made this length and that length. So if we added E to F, we know it's equal to C, just using segment addition. Using segment addition, we know that E plus F is equal to C. So E plus F is equal to C, just using segment addition from our diagram. So now we can substitute this in. We could say A is going back to this equation, A squared plus B squared is equal to C times E plus F. Well, we know E plus F is C, so C times C. What just happened? We could rewrite this. I guess we would just call this, we did substitution. And let's rewrite this one more time. A squared plus B squared is C squared. I guess you would call that simplifying it, to be able to write it in a simpler way, C squared. We did it. So mission accomplished. Great job, guys. Check out the next video for the rest of the questions.